Hi, Geometry. Today we're doing Unit 3, Lesson 4, and we're on page 335 of our workbooks. And we're going to be measuring angles using a protractor. So it's okay if you don't have a protractor. It's just one minor part of this lesson. And in this picture, let's see what we have here. We have triangle A prime, B prime, C prime. That's my image. It's a dilation of triangle ABC. That's my original with center P. So this is my center. They grew from my center, and my scale factor was 2. So if this is true, then I know my original triangle ABC is similar to my image, triangle A prime, B prime, C prime. And if they're similar, we've been talking about how corresponding angles are congruent and sides are in proportion. So why don't we look at that? Why don't we measure two of these angles? Let's measure angle C and angle C prime and see if they are congruent. To measure angles more easily, sometimes we extend the sides longer. So what I've done here is I've lined up C prime, A prime, and I've made that longer so I can measure this purple angle. And then I've made AC longer so I can measure this purple angle. So this is my protractor. And to measure an angle, I put the vertex in the center, and then I line up this line at the bottom with the bottom of my angle. And then I use these numbers to measure. So which numbers am I going to look at? Well, this is pointing to 0. So this is the beginning of my angle, and my angle goes up to this long purple line that I extended. So I'm not going to go from 0 to 170. I'm going to go from 0 to 10. So this is 10 degrees, 20 degrees, 30 degrees, 40 degrees, and my line crosses halfway in between 40 and 50. So then this is 45 degrees on my protractor. I can see it going through the middle tick mark. So I know that C prime is 45 degrees. So let's see what angle C is. Angle C, again, I put my vertex in the middle right here, and then this line lines up with the bottom of my angle and points to 0. So I go from 0 to 10, 20, 30, 40. Looks like my line, it doesn't quite reach it. I didn't extend it long enough, but my line is halfway in between 40 and 50, the side I'm using. And so this also is 45 degrees. If I took the time to measure A prime and A and B prime and B prime, or B and B prime, I would find that those were also congruent because my angles are congruent and my sides are in proportion. So let's go ahead and verify that real quick. If my scale factor is 2, that means my side length should be doubling. So let's go measure BC. If I measure BC, it looks to me like it's 1 tick mark after 2.5. So this is 2.5 centimeters and 1 more tick mark, or 6 tick marks. So this is 20 millimeters and 6 tick marks. This is 26 millimeters. So let's see, what would be twice that? That would be 52 millimeters. Let's go see if C prime, B prime is 52 millimeters. So I go over 5 centimeters, that's my 50 millimeters, and 1, 2 tick marks. It is 52. So this activity is showing me that my corresponding angles are indeed congruent and that my sides are in proportion, which is what we've been learning in class. So let's take a look at number 1. It says, what do you think is true about the angles of my image compared to the angles of my original? Well, we know that our angles are congruent. They've not changed. My angles don't double. My angles are not affected by my scale factor whatsoever. So angle A is congruent to angle A prime, angle C is congruent to angle C prime, and angle B is congruent to angle B prime. So then I want to talk about, and that's true for any dilation. So now I want to take a minute and go back and talk about the lines for just 1 second. So at the top of this, you can see that the title was dilating lines and angles. So I want to take just a moment and talk about the lines of a dilation. We've mentioned this before, but the CB is parallel to C prime B prime. And side AC and side C prime A prime are parallel, and AB and A prime B prime are parallel. So I want to take a moment using this angle C and just show you something you should recognize from Unit 1. So if I extend this side a little bit and make BC longer, B prime C prime longer, and I do the same thing to BC, and I draw in that line that connects B to C and C prime. So now I'd like you to focus in on my purple lines. Do you see how this looks very similar to the parallel lines cut by a transversal from Unit 1? So I'm focusing on this being my transversal. This would be my transversal. And this would be my two lines that I am crossing with my transversal. This would be that angle that would be corresponding angles right here, this entire thing, not just the 45, but this entire angle. And those two angles are congruent. The entire penciled arc mark I'm making and the entire penciled arc mark I'm making. So I also know that a dilation takes a line to a parallel line. So I want to put that note on this page as well. We know that a dilation takes a line to a parallel line or itself. This should sound familiar to you. This is exactly what a translation did in Unit 1. So if it's sounding familiar, in Unit 1 we had a translation takes a line to a parallel line. Now we have a dilation takes a line to a parallel line. So in this picture, I know that CB is parallel to C prime B prime. I know that AB is parallel to A prime B prime. And I also know that AC is parallel to A prime C prime. So a dilation takes a line to a parallel line or itself, and we'll look at that later. Thank you very much.